Welcome to the tutorial on error bars and data fitting in GNUplot. In this tutorial, we will learn to add error bars in a plot, learn about data fitting, write an equation to fit the data, make initial guess for value of the coefficients, fit the dataset to the equation, and draw an arrow object in the graph. To record this tutorial, I am using Ubuntu Linux 16.04 OS, GNUplot version 5.2.6 and gedit version 3.18. To follow this tutorial, learner must be familiar with the basics of GNUplot. For the prerequisite tutorials, please visit this site. The files used in this tutorial are provided in the code files link. Please download and extract the files. Go to desktop. I have a y error type data in a text file. The first column is X data. The second column is Y data. The third column is error in the Y data. Open a terminal, change the directory to desktop and open GNUplot. I will clear the screen. Let's plot the data to see the trend. Enter the plot command as seen on the screen. Command colon 3 with Y error bars adds the error to the plot. If error limits are on the X data, we have to use X error bars term for plotting. The graphics window opens. Let's fit this graph to an equation. Here the data points are likely to follow an exponential decay. The points deviate from an accurate exponential decay. This could be due to measurement errors. We will fit the given data points to an exponential decay function. Let's see a few steps involved in fitting data points to an equation. Define an equation to represent the data. Make initial guess values for the coefficients in the equation. Optimal values for the coefficients are found by an iterative process. Check the goodness of the fit. A good fitting is measured by a low value of chi-square and display the fitted data with the starting dataset. First, let's define the function. In the GNUplot prompt, type f of x is equal to a times e to the power minus kx. Make an educated initial guess for the values of a and k. Go to the graphical window. From the graph, I will place the initial value of a at 150,000. For an exponential decay, I will place the initial guess of k around 0.5. Close the graphical window and go to the GNUplot terminal prompt. Enter the commands to set initial guess values. Set a to 150,000 and k to 0.5. To fit the data, type the command fit f of x in single quotes the file name. Here it is xydy.txt. Then using 1 colon 2 colon 3 via a comma k. Here a and k are the coefficients. We could leave out the colon 3 part in the command. Then errors in the Y data are not considered during the data fitting process. Press enter to run the data fitting algorithm. The coefficients in the equation are optimized by an iterative process. The output is generated on the screen. Let's scroll up. I see an error warning message on the top. Notice a table with chi-square and new values for a and k after each iteration. The program reports that the fitting process converged after 10 iterations. Many fitting parameters are reported in the output. Program reports final sum of square of residuals. Notice relative change in values after the last iteration. The number is very small. Degrees of freedom is 9. RMS of residuals is around 2.5. Updated values of a and k and their error in estimation is also shown. The correlation matrix of variables is at the end of the output. Now we have a function that fits the given data points. Let's plot the data points and the function together. I will clear the screen. Enter the command as seen on the screen. This plots the data and the function together. We are plotting the fitted equation along with the initial data points. The fitted data is represented by a line. I am specifying the legend for f of x as fitted data. No legend title is added for the starting data set as no title is mentioned. I have specified a filled circle symbol and 1.5 for point size. Data points are represented by symbols with error bar and without a line style. Let's also set x-axis limits with setXRange command as seen. Replot to see the results. Check the GNUplot website for example scripts on data fitting. Next, let's draw an arrow object in the graph. In the graph, I want to add an arrow. I will note down the coordinates as seen in the graphics window. Go to the terminal. Enter the commands as seen on the screen. Here 1 is the name I have given for the arrow object. Replot to see the updated result. I will also add a second arrow in another direction. Go to the terminal and enter the command as seen on the screen. I will name this arrow as 2. Replot to see the updated result. Now we see 2 arrows in the graphics window. I want to remove one of the arrows. To remove the object, we have to unset the object. Hence, go to the terminal. Enter the command unset space arrow space 1 to remove the first arrow. Replot to see the updated result. The arrow that was named 1 is now removed from the graphics window. Close the graphics window and quit GNUplot. To summarize, in this tutorial, we incorporated error bars in a plot, fitted a given set of data points to an equation, plotted the fitted curve along with parent data, added and removed an arrow object. For the assignment activity, please do the following. For the data file assignment.txt, make an XY graph with XY error bars. This file is available in the code files link. Fit the data to a double exponential decay curve with Y error bars. Plot the fitted data. Draw an arrow object in the graph at the position of your choice. The completed assignment looks similar to this. This video summarizes the Spoken Tutorial project. Please download and watch it. We conduct workshops and give certificates. For more details, please write to us. Post your timed queries in the forum. Spoken Tutorial project is funded by MHRD, Government of India. This is Rani from IIT Bombay. Thank you for joining.